Oh, good evening, my dear JEE warriors. I know you guys were waiting for this session for a long time, and finally, this session is here. Relative motion in 1D as well as 2 dimension. All the concepts, all important theory pointers, which will also include the Rainman problems, riverboat problems, relative motion in 1D, closest approach, also the questions of where under gravity also some questions are there with relative motion. All these kind of questions will be dealt in today's lecture. Okay, so let's get started with your captain Shreyas, your physics master teacher. Hello Sadia, hello Dharnishwaram, home thief, welcome Nikhil, welcome everyone. Hello Tom, good evening, vanakkam pasangla, vanakkam vidyarthigalu, welcome everyone. Hello Peter. So I hope you guys are all excited, and quickly mark your attendance in the bottom. Yeah, you will see that like button. Quickly mark it over there, and also quickly subscribe to the Vedantu J English channel. So let's begin with the class, and let's talk about what is relative motion. What is relative motion, right? Guys, tell me quickly, who is your favorite actor or actress? Who is your favorite actor or actress? Quickly, then we'll start the class. Hello Sudarshan, hello Devna. Motion in a straight line already done, bacha. Motion in a straight line is already done. In case you have missed those classes, it's there right now over here. You will see, if you go back a little bit, current electricity done, part of it, remaining part will be done, ray optics done. You can see before, oh my god, yeah, motion in 2D, you can see right over here. Motion in 1D was done in 2 parts. This is the second part, motion in 1D, motion in a straight line, yeah. Okay, so thank you so much, Nikhil. Nikhil's favorite hero is Shreyas Sir. Thank you. Even my favorite hero is me only. My favorite heroine keeps changing. So you can see everybody is giving different answers. Somebody saying Samantha. Oh, interesting. Thalapati Vijay. Yeah, very Rajnikant. See, everybody has their own choice. So this concept of who is your favorite hero or who is the best hero is a relative concept. Same way, my dear students. Motion is also very relative. It depends on the observer. If you ask somebody, Pandu will say, hey, Champa is moving. If you ask another Pandu, hey, Champa is at rest. Another Pandu will say, Champa is moving very fast. Another Pandu will say, no, Champa is not moving at all. So this perception of motion is also relative. Understand that. So the perception of motion itself is basically relative in nature. So let me add the pointers over here. Motion is relative, and this perception depends on the observer. It depends on the observer. It can't be absolute. It is not absolute. So the same Champa who is probably going somewhere, for one Pandu over here might be at rest, for another Pandu over here might be in motion. So it depends completely on the observer, and that observer is usually denoted as something called as the frame of reference. It depends on the observer. And what do we call the observer? The observer is your point of view, which we also call it as the frame of reference. Frame of reference. Is that right? So if you tell from the frame of reference of a train, the passengers inside are at rest. From the frame of reference of the railway station, the passengers in the train are in motion. From the frame of reference of a train coming in the opposite direction, the passengers in the other train are moving really fast because they are going in the opposite direction. Is that right? Yep. Arjit, yes, I think most of it is uploaded. If something is pending, I will get it uploaded. You can just mention it in the comments later on. Yes. All right, Arjit. I'll have a check. I will have a look at all the DPPs. If anything is pending, I'll get it uploaded in the Jungle Book. Okay, so don't worry. I'll definitely get it uploaded. Now, when we talk about relative motion, when we talk about relative motion, usually we divide the problems into two categories: relative motion in a straight line or one dimension, and relative motion in two dimension. Okay, so in one dimension, usually it is very straightforward. For example, for example, imagine imagine there is a champa. Imagine there is a champa, and we have a pandu over here moving towards each other after a long time. Imagine they had a breakup and they are meeting each other after a long time. How excited they will be. Pandu will run towards Champa and Champa will also run towards Pandu. So Champa is running like this with some speed, let's say V1, and Pandu is running towards Champa with a speed V2. So then their relative speed with respect to each other. If Champa sees Pandu or Pandu sees Champa, they will see each other moving towards each other with a speed of V1 plus V2. This is just adding their magnitudes. If it was 2 meters per second, this was 3 meters per second. 2 plus 3 will be 5. So Pandu will see Champa coming towards him with a speed of 5 meters per second. Is that right, everyone? If they have a breakup, they will run away from each other. They will be like, I will not talk to you. I will not talk to you for a long time. I will not talk to you for a long time. And Pandu and Champa move away from each other, V1 and V2, right? Still the relative speed will be V1 plus V2. I hope you agree with this. I hope you agree with this, because if I move 2 meters, Champa also move 3 meters away from me. So total separation will be 2 plus 3, which will be 5. So whether moving towards each other or away from each other, understand the speeds, magnitudes will basically add when you find the relative motion. Is that agreeable? Yes, it is a detailed series, Ahmed. Yep, you can see everything is being explained right from the basic concepts. So whether you approach or whether you move away from each other, relative speed will be calculated by adding their individual speeds. But before they had a breakup, before they had a love story, this is long time ago, guys. This is long time ago, guys. So imagine we had our Pandu, over here. We had our Pandu over here, and this Pandu moving with a speed V2 was following that Champa. Champa was moving. This is before he asked her out or something. So Pandu was following Champa. Champa was moving nicely in a garden one day. Pandu was just following her like a cool dude. And then their relative speed, my dear students, then their relative speed, think about it. If Champa moved 3 meters, Pandu moved 2 meters in the same direction. Champa moved 3, Pandu moved 2. So their separation is changing at a rate of 1 meter per second. Think about it. Champa moved 3, Pandu moved 2. So their separation is only changing by 1, which is the subtraction of their speeds. Hence, it will be the V1 minus V2, whichever is bigger comes first. Whichever is bigger will come first. Agree with this? Yep. ZZ, hello Rina. After Newton's laws, obviously, we'll have work per energy. Friction and Newton's laws will be taught together. Don't worry. Now, see, Pandu was following Champa. Champa did not give bhav only. She didn't look at Pandu. Then one day what happened? Pandu also got fed up. He's like, she's throwing attitude. I will also throw attitude. So Pandu walked away. Champa was like, what the hell? Why is he not following me? So that day what happened? Champa started following Pandu. So now you can see our Pandu is going like this with a speed of V2, and our Champa is following, worried. Why is he not coming towards me? And she is following Pandu. In this case also the relative speed will be V1 minus V2. The mod of it, whichever is bigger will come first to make it positive, because we are talking about speed. Okay, so I hope you understood. These are the only 4 possibilities. Apart from these 4 possibilities, there is no other possibilities in relative one dimension motion. In one dimension motion, there is no other possibilities. Lucifer, you missed the love story, man. Okay, thank you for all the love from Tamil Nadu. When I was born in Tamil Nadu, Salem, right? All right. So Pandu Champa fight, move away, add. Pandu, Champa meet after a long time coming towards each other, add. Basically, they are coming towards or going away simultaneously, add. If one is following the other or the other is following the one, then it is subtract. As simple as that. But often this can also become confusing. Is there like a rule of thumb which always works, sir? I get confused with this also. No issues. I will tell you the rule of thumb, the basic rule for relative 1D motion. So whenever you write something like this, velocity of A with respect to B, what it means when you put two subscript, it means velocity of A, of object A with respect to B. In such a case, understand B is the observer. B is the observer, basically your point of view or your frame of reference. And your A, this A is the object being observed. That is being observed by the observer. So naturally, if I put VBA, it is then velocity of B with respect to A. In this case, our A becomes the point of view or the frame of reference, and then B becomes the observed quantity. B becomes the observed quantity. So VPC, if I say velocity of Pandu with respect to Champa, VPC means Champa is seeing Pandu. If I say VCP, then it means velocity of Champa with respect to Pandu. So Pandu is the observer, Champa is being observed. Is this nomenclature clear? Is this nomenclature clear? Then I will show you the rule of thumb. Is this nomenclature clear? Okay, awesome, awesome. Yes, Sadia, I will be uploading it, don't worry. All right. Now, what is the value of this? The answer to that question is, whenever I write VAB in vector form, it is always velocity of A minus velocity of B. And the reason for that is very simple. When I say velocity of A with respect to B, that means I'm seeing A as an observer of B. So whatever velocity B has to be taken out from A. So whatever is remaining is what B will see when he sees A. I'll repeat once again. When I say VAB, B is the observer, A is being observed. So if B is the observer and B itself is moving, so I need to take away B's velocity. So from A's velocity, you subtract B's velocity. From A's velocity, you subtract B's velocity. Whatever is remaining is the relative velocity. I hope this is clear. Same way, I will also say VBA is VB minus VA. VB minus VA, right? This also works not just for velocity, but even acceleration. So I can also say acceleration of A with respect to B is acceleration of A minus acceleration of B. I can also say acceleration of B with respect to A is nothing but acceleration of B minus the acceleration of A. I can also use this for displacement. So displacement of A with respect to B is, and displacement of B with respect to A is, this will be nothing but displacement of A minus displacement of B. This will be nothing but displacement of B minus displacement of A. As simple as that. So it works for acceleration also, it works for velocity also, it works for displacement. All these three things. One more interesting thing, VAB and VBA, if you see, the order of the events is different. Same thing here. So can I just not say VAB technically is negative of VBA? It's just the negative of VBA. That's it. You just negate this, you will get this. Not just that, even acceleration of A with respect to B is negative of acceleration of B with respect to A. Is that right? Same thing for displacement also. I can say displacement of A with respect to B is a negative of displacement of B with respect to A. So they are just negatives of each other. Velocity of A and B is with respect to whom? Yes, very interesting question. Very interesting question. Now, when I write VBA or VAB, the observer is understood to be A or B respectively. But, sir, when I just write velocity of A, who is the observer? Who is the observer? The answer to that is ground is the observer. Ground frame of reference. Ground frame of reference. When the second subscript is missing, when the second subscript is basically missing, or even if I put something like just v or just velocity without mentioning the subscript, it is understood it is the ground frame of reference, that is your earth, that is basically your earth. So velocity of A is the same as velocity of A with respect to the ground. This is the ground frame. This is the ground frame. So you are allowed to skip that second subscript. So when I say the ground frame, you should always think of probably the trees, probably the buildings, whatever. Okay, so that is basically your ground frame of reference. That is your ground frame of reference. Is that clear, everyone? Yep. Awesome. 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 Ring theory. Which is ring theory, man? Deepak. Which ring theory you want to study for JEE? No ring theory is there for JEE. Don't worry about it. Okay. Moving on. Moving on. Now, here I can also tell you one more thing before going ahead. Just like I said, velocity of A with respect to B, if let's say for example it is this vector, then the negative of that will be exactly opposite. This will be velocity of B with respect to A. You can see they are just negative vectors. They are just negative vectors. Negative vectors when your observer and your object is basically interchanged. When your observer and object is nothing but interchanged. That's all. So when the observer becomes the object and the object becomes the observer, they are just negative of each other. It kind of makes sense. If I am Pandu looking at Champa and Champa is coming towards me slowly, so from Champa's perspective, Pandu, as she is going, will come towards her this way. Correct? So for the Champa, understand Pandu will come like this as she is walking close towards him. And for Pandu, for Pandu, Champa will come this particular way. Okay. So for Pandu, Champa will come like this towards your left side. For Champa, Pandu will go towards your right side. Will go towards your right side as she goes close to Pandu. Understood, my dear warriors? Till this point, is everything absolutely clear? Let me know quickly in the chat box. Let me know quickly in the chat box. Good evening, Adiksha. Awesome. Now that you have understood it till here, can we take some examples before going ahead? And also let me remind you of one more thing. Not all the quantities are relative. Not all the quantities are relative. Okay. For example, force. Never write force of A with respect to B is FA minus FB. There is nothing like relative force. This is completely wrong. Same thing with many other quantities like sir, electric field of A with respect to B. No, doesn't make sense. Okay, only certain quantities have relativistic behavior like displacement, velocity, acceleration. They depend on the frame of reference. So imagine this. I tell you, car A has a velocity of 4 meters per second towards east, and car B has a velocity of 10 meters per second towards the west. Can you find quickly what is the velocity of A with respect to B? Well, if you simply use the rule of thumb which says it is VA minus VB. Think about it. VA velocity of car A, it is going towards the east, towards, let's say, this side, right side. So it will be 4 I cap minus velocity of B, 10 meters per second, west side. West is, let's say, towards the left. So it will be minus 10 basically I cap. So minus minus becomes plus. So it will just become 14 I cap. It will just become 14 I cap meters per second. That is the answer. Same way, if somebody tells you the velocity of B with respect to A, it will be VB minus VA. What is B's velocity? It is negative 10 I cap because you are going towards the west. A is 4 towards the east, so plus 4 I cap. So this will become minus 14 I cap. And as expected, they are just negatives of each other. They are just negatives of each other. Okay. Similarly, imagine there is a person who is basically, let's say, falling down with the help of, let's say, a parachute, and his acceleration towards the ground, example, is let's say 7 meters per second square, not so much, as compared to another person, who is directly falling without any parachute. So his acceleration due to gravity will be 10 meters per second square. Is that right? So now if I ask you to find the relative acceleration of this Pandu, let's say this is Champa, with respect to this Champa. So how do you find out? Let's find it out, guys. Acceleration of Pandu with respect to Champa. You need to decide which side is positive, which side is negative. Usually we take upwards as positive. So let's consider upwards as positive, guys, as usual. So it will be nothing but acceleration of Pandu minus acceleration of Champa. What is acceleration of Pandu? Pandu is going down negatively 7, and that too j cap, minus 7 j cap, minus Champa is going down, so minus 10 again j cap, right? So minus minus will become plus. 10 minus 7 is just 3, so it will be just 3 j cap meters per second square. Is that right? And if you do the exact opposite, acceleration of Champa with respect to Pandu, which is AC minus AP. AC, Champa's acceleration is negative 10 J cap. Pandu's acceleration is negative 7 I cap, right? So this will become plus, and minus 10 plus 7 is basically minus 3 J cap meters per second square. That is what you will get the acceleration as. So what does this also mean? If Champa in the first case, were considered or was considered to be the observer, she will see this particular Pandu who is coming down with this particular parachute, she will see him going with an acceleration of 3 j cap. 3 j cap means upwards, positive. So with an acceleration of 3 meters per second square upwards, she will see Pandu going up with more acceleration of 3 meters per second square. It makes sense because she is going more down as compared to Pandu. She is going more down, so she will see Pandu going up. Even though for the earth, Pandu is coming down. Is that clear, my dear warriors? Yep. Yes, Nikhil, Pandu will be going up. And for Pandu, Champa will be going down with 3 meters per second square because Pandu is going down slowly a little bit as compared to Champa. That is what is happening, my dear students. Now, the same concept is also applicable even in 2 dimensions. So this is the basic theory. There is nothing different over here. The same logic is even applicable even in 2 dimensions. Say for example, our Champa, wow, we are calling her our Champa, is moving like this with a speed of, let's say, 5 meters per second, or let's say 5 meters per second. And let's say our Pandu is moving towards the north with a speed of 12 meters per second, example. Okay, so Pandu, Champa over here. So this is Champa, this is Pandu. Now I ask you a simple question. What is the velocity of Champa with respect to Pandu. By definition, it is Vc minus Vp. Now think about it. Champa is going with a speed of 5 towards the positive side of the x-axis. So I will put 5 I cap minus velocity of Pandu is 12, but in the north, in the y-axis direction, so plus j cap. That's it. That is the answer. This is the relative velocity of Champa with respect to Pandu. What does it mean? So if Pandu was made the observer, if Pandu is made our observer, the frame of reference, 5 I cap is right, minus 12 j cap is down. So 5 I cap minus 12 j cap, that means it will be like this. So for him, Champa will be going in this direction. Champa will be going in this direction. That is what he will see. That is what Pandu will see Champa doing. You don't have to visualize anything. Automatically, these equations give you the answer. That is why I said rule of thumb. Similarly, if I say velocity of Pandu with respect to Champa, which is Vp minus Vc, Vp is 12, but j cap. Velocity of Champa, 5 I cap. That's it. That is the answer. Velocity of Pandu with respect to Champa. So this time alone, Champa is our observer and she sees our Pandu going 12 j cap minus 5 cap. 12 j cap minus 5 cap. That means somewhere here, that is what she will see this Pandu doing. She will see Pandu going this way. You can say this is exactly opposite to this one. Pandu sees Champa coming like this. Champa sees Pandu going like that. Exactly opposites of each other. Yeah, everyone? Okay. Now if I ask you what is the magnitude of this, it's not that difficult. If somebody asks you what is VPC's magnitude, it will be root of 12 square plus 5 square, which is root 144 plus 25, which is 169, which is 13 meters per second. Wow. Champa sees Pandu going like this with a speed of 13 meters per second, and Champa sees Pandu going like this with also the same speed but in opposite direction. That's all. That is all that is there in relative motion, even in 2 dimension, even in 2 dimension or even in 3 dimension. Yep. Now you can have some more complex questions, something like this. Say, for example, I tell you VAB is equal to VA minus VB. It was understood that our frame of reference was ground. It is understood that our frame of reference was nothing but ground. But if this G is replaced with some other alphabet or some other object or some other frame, how does it matter? So generally speaking, can I also say VAB will be VAC, C is something, I don't care, minus VBC. This C and this C should be the same. This and this should be the same. As long as they are same, I am okay with it. Let's rearrange it. So it will become VAB plus VBC is equal to VAC. This is a very interesting thing. Look at this. This is A. Oops. This is A is also over here, and then it ends with C. C is also over here. This tells me this is like the chain rule in relative motion. This is like our chain rule in relative motion, my dear students. Observe this carefully. You start with some variable. Like, for example, A. Then you shift it off to something like B. You can then go to some D. You can go to E. You can go to F. You can go to H, I, J, whatever you want. But at the end, you have to end it with the same variable over here. That's it. So this is exactly the chain rule, but in a relative motion. Exactly. So generalizing this, I can say that our chain kind of rule in relative motion, which is there in relative motion. So V A and then B will be equal to V. If you started with A, you have to start with A. You can go to anything else. You can go to C plus VCD plus VDE plus whatever you want. How many ever alphabets? Let's say I decide I got bored, I got tired, I want to end now, so I end it over here. So this is how it goes. This is the chain rule. You can make this as long as you want. You can make you can make this as long or short as needed. Okay, this is very, very important. Okay, many people do not know about this particular rule of transitioning from one variable or one frame to the another frame of reference. Like for example, let me show you. Say it is told to you Champa is in space. Wow, Champa has now gone to space. She has now become an astronaut. And there is another moon or something from which Champa is being observed. And there is, or maybe there is another satellite or some international space station. God knows, some spaceship is there through which all the observations are being made, and that spaceship has taken off from some moon, and this is our beautiful little earth from where the spaceship was uh, launched and everything else. And let's say you want to go from one frame to the other frame of reference, and I tell you, you know what is the velocity, of Champa with respect to the earth? With respect to the earth, you can say, okay, sir, I know the velocity of the Champa with respect to the spaceship, sir. With respect to the spaceship, sir. Champa is this one, velocity of Champa. Sir, the spaceship's velocity, I know it with respect to, sir, the moon, sir. The moon, sir. The moon is over here, okay, with respect to the moon. And then finally, I know the velocity of the moon with respect to the earth. So I'll end it over here like this. And each of them can be given to you. It could be anything. Maybe this quantity is maybe 12 I cap minus j cap. Maybe this particular quantity could be I cap plus 2 j cap. Maybe this quantity could be minus 3 I cap plus 2 j cap. Anything. So adding all these numbers, what do we get? Well, 12 plus 1 is 13. 13 minus 3 is 10. So here I'll get 10 I cap. And over here, minus j, 2j and 2j will become 4j. 4 minus 1 is basically 3. So plus 3 j cap. So that is the velocity of Champa with respect to the earth. With respect to the earth. That's how you go about it. So here I knew the velocity of the moon with respect to the earth. I knew the velocity of spaceship with respect to the moon. I knew the velocity of Champa with respect to the spaceship. So indirectly, I found her velocity with respect to the earth. Is that right? Abhivarshini, apart from the lectures, there are many more things. Obviously, you get your extra DPPs, you get the coaching module, you get doubt solving, you get post-class doubt solving, you also get additional material, right? You also get access to a lot of ebooks from various publishers. You also get PYQ revision classes, you get revision classes, you get support till JEE Advanced, you get JEE Advanced content, you get Eklavya content, plus you get mentorship, plus you get monitoring in the class. Any problems happen, everything you can directly ask the teachers, and of course the support till the counseling. So a lot of advantages, right? And plus you have the quizzes and other things to talk about. Great. So now that we have understood how this relative motion works, and by the way, this also works for acceleration, all right, or even displacement for that matter. Say for example, there is a ball thrown like this and it is going in this particular manner. There is a ball thrown like this, okay, there is a ball thrown like this, it's going in this particular manner, okay, so this is our ball, and maybe there is a train, over here, which is accelerating at maybe, I don't know, maybe some 6 or maybe some uh, 20 meters per second square, like this. So now if I ask you, what is the acceleration of the ball with respect to the train? What will your answer be? Think about it. Acceleration of the ball with respect to the train. You will think, okay, it will be nothing but acceleration of the ball minus acceleration of the train. Okay, fair enough. What is the acceleration of the ball? Anything which is thrown like a projectile always accelerates due to gravity, g, always pointing towards the center of the planet, that is downwards in this case. So it should be minus 10 j cap. Minus 10 j cap is the acceleration of the ball. Minus, what is the acceleration of the train? It's going like this. So it is minus 20 I cap. I cap is the x-axis, negative x-axis, because it's going towards that side. So this will just become minus minus is plus. So 20 I cap minus 10 j cap. 20i is basically like this, minus 10j is basically like this. So this is the acceleration of the ball with respect to the train. It's like this in this particular direction. And the best part is this is a constant. This is a constant because there is no time in this equation. There is no time also in this equation. Kinematics, this is the last class, fastest creative. Yeah, we did 1D separate, we did 2D separate. We have given enough importance to every lecture, every topic in detail, right from basics to all the concepts and also the application of these theory points. Cool. Shall we now do some questions? This is the main theory. Let me tell you, the entire backbone of this chapter is exactly this one. This chain rule and this basic rule of thumb of how do you calculate all these things. Okay, we'll go to some questions, but one last thing before I go ahead, which I need to also tell you, is this one. What do you think about the kinematic equations? Are they still valid in the relative frame? Do you think kinematic equations are valid in the relative frame? The answer to that is yes. So when I write V12 is U12 plus A12 into T, there is nothing wrong in it. But make sure this is 2, this is also 2, this is also 2, this is 1, this is also 1, this is also 1. Don't change the variables. Same way, displacement of 1 with respect to 2 is velocity of 1 with respect to 2 plus half into acceleration 1 with respect to 2 into T square. Same thing, V12 square is U12 square plus 2 A12 dot S12. All these equations are valid. Displacement in the nth second of 1 with respect to 2 will be also u of 1 with respect to 2 plus a by a12 by 2 into 2n minus 1. Yes, that's it. So all these equations still hold true as long as your frame of reference is the same, consistent. And one last important thing is the relative acceleration is a constant. Remember, otherwise you cannot use it. Derivatives and integration is the other option. So as long as the acceleration is uniform, only then you can use the kinematic equations. Cool? Awesome. Awesome. Circular motion will come after this, not now. It will do it after Newton's laws. But see, I'll tell you, NCERT flow is the worst flow, especially for 11th grade, because they have jumbled up the chapters like crazy. I mean, like they have mixed vectors somewhere, then have mixed circular motion, kinematics in motion in a plane. Then suddenly again circular motion comes in, laws of motion. I mean, really, guys, I mean, that flow is really messed up. So, JEE teachers, JEE coaching centers, and this has been not my rule. This has been a rule since last 20, 30, 40 years. That is how JEE students get trained. They do not follow the NCERT flow. Okay, there is a completely different flow altogether. Okay, so mind that. All right, cool. So, moving on to some questions coming up on your screen. There is a train moving at some speed overtakes a man running on the platform in the same direction. How long the train will take to cross the man if he was running in the opposite direction? Let's try to think about it. So, yep, the train is 100 meters long and is going. So, this is our train. This is 100 meters The train is basically 100 meters long and it is going at 15 meters per second. And then you also have this person which is there. You also have this person who is going at a certain speed in the same direction, whose speed is not given. Okay. Now, if this train has to overtake the person, and I want to see the time calculation, either sit on the train or sit as or make yourself the person. I think that will be easier to understand. So if I make myself the person, then my dear students, if I just make myself the person, that means I will be at rest, the person will be at rest, and the train will appear at which speed? The train will appear at which speed? Think about it. 15 plus you or 15 minus you? Recollect Champa Pandu. Pandu falls in love with Champa walking in the garden. Champa is just going casually. Pandu falls in love. He starts following her. What is the relative speed? Minus, right? The bigger minus the smaller. Who is bigger? Train is bigger than the speed wise than the person. So it should be 15 minus u. Remember, anybody following the other one in the same direction, it is negative. Opposites is positive. Opposite. Remember, opposite symbol is what? Cross, right? So if you turn it like this, it will become plus. Opposite direction is like this, so you turn it like this, so it will become positive symbol. Is that right? Perfect. Now, this scenario, I can just say, using the concept of time and speed and distance, right, is basically your speed, distance, time, and speed, right? So the distance which the train will travel is nothing but 100. In how much time? Well, in 10 seconds. This is 15 minus u. Therefore, 100, 10, 0, 0 cancels. So 10 is 15 minus u. So u will be 15 minus 10, which is 5 meters per second. Perfect. We found the speed of the person. Now the next scenario, in the next scenario, what is happening? The person is going in the opposite direction. The person is going in the opposite direction. The train is still moving at 15 meters per second, but this person is basically going like this with 5 meters per second. This scenario, you can convert it as if the train now is going with a different speed and the person basically is at rest. In opposite direction, turn it, it becomes plus. You add the speeds, so it should become 20 meters per second if you were considering yourself to be the person. And the person moving in the opposite direction, train is going against me, the speeds will add, it will become 15 plus 5, which is 20. Using the same concept, distance, time, and speed. Distance is 100, time do not know, speed will be obviously 20, so naturally time will be 100 by 20, which is 5 seconds. That should be the answer. Yep, you can see it right over here. Is that clear? Oh no, Dharneshwaram, answer is not 3, my dear student, it is 5 meters per second. Be careful. Shall we go to the next question coming up on your screen? Warriors, have you liked the session? Have you subscribed to the channel Vedantu JEE English? Yes or no? If you have not done that yet, please do that. Should we do HC Verma, at least the objective questions, short answer questions, and the theory with the solved examples? These are the 4 major things which you must do. Must do is objective 1 and 2, short answers, theory, and solved examples from HC Verma. If you do not have other coaching modules and other stuff, otherwise not needed, because most of the coaching modules already include those HC Verma questions in one or the other way. Yep. Train A, this is JEE 2024 question. A is moving parallel, okay, along 2 parallel rate tracks towards north with speed of 72, and B is moving towards south with 108 velocity of B with respect to A and velocity of ground with respect to B. Oh, interesting question, guys. Interesting question. See, A is basically a train which is going towards north with speed of 72. How much is 72, guys? Multiplied by 5 by 18. Multiplied by 5 by 18. How many times does it go? 4 times. So 4 5s are 20. So it will be 20. So train number A is going with a speed of 20 meters per second. Train number B is going towards south with what speed? Multiplied by multiplied by 5 by 18, it goes 6 times 6 5s are 30. So 30 meters per second downwards like this. Okay, perfect. So now the question is velocity of train B with respect to A. Velocity of train B with respect to A will be VB minus VA. Velocity of B is negative 30 j cap, negative 30 j cap, minus velocity of A is plus 20 j cap. So how much will it be? 30 and 20 will add now. It will become minus 50 j cap. Minus 50 j cap is velocity of B with respect to A. Similarly, if I want to find what is the velocity of ground with respect to B, guys, velocity of B is how much? Minus 30 j cap. When I say VB, it is actually velocity of B with respect to G. Is that right? Now, what is velocity of ground with respect to train B? It's exactly opposite. So it will be negative of VBG. It is negative of VBG if I interchange the variables. So it is minus of minus 30 J cap. So it should be plus 30 J cap. It should be plus 30 J cap. Option number B is the correct answer. Minus 50 is the first one. Plus 30 is the second answer. Very good. B for IIT Bombay. Very good. Dharish Varan. Very good. EC2 Nikhil. Made a mistake. Yes, home thief. Perfect. Perfect. Everybody understood? Very good, Tom Harborine. Just use the rule of thumb. This has been asked in JEE 2024. Can you believe that? Moving to the next one. Passenger sitting in a train moving at 90 observes another train moving in opposite direction for 8 seconds. The velocity of B is 54. The length of the train is how much? Okay. So let's visualize, let's draw, and then make the equations. Train A, this is the train A's passenger. Train A's passenger moving with 90 kilometers per hour. You multiplied by 5 by 18. Multiplied by 5 by 18. 5 5s are 25. Yes. So train A is going at 25 meters per second. Perfect. What about train B moving in the opposite direction for 8 seconds? Moving in the opposite direction for 8 seconds. Okay. So this is train number B. And what is the speed? 54 kilometers per hour. 54 if you multiplied by 5 by 18 threes are, so 15 meters per second, right? So this is going to be 15 meters per second. So if you make yourself as the observer, if you make yourself as the observer A, what will that observer A see? What will that observer A at rest see the train doing? Just think about it. Relative speed, how much will it be? Guys, the trains are moving in opposite. What did I say? Opposites means add the speed. So 25 and 15 will make it 30. So he will see the train going at 30 meters per second. So the front of the train will cross and it will take some time. How much time? 8 seconds till it reaches the end. So again, using distance by time is the speed. Distance is the length of the train. Time is 8. Speed is 30. Hence, the answer for the length of the train, 8 threes are 24. So 240 meters. Where is 240 meters? Why is it not there? Something is wrong. Opposite direction, observes the train. Did we do some mistake, blunder? Just check this out. 740. Oh, why did I write 30? My bad. Sorry. Yes, 15 and 25, that is 40 meters per second. And now using distance by time is equal to speed. Distance is the length of the train. This distance, time is basically 8 and our speed is basically 40. So length is 8 fours are 32 and one more 0. So 320 meters. Yes, it is the correct answer. Perfect. Cool. Everybody? Awesome. Moving on to the next question on your screen. Now I can see some acceleration also in the question. So let's read it carefully. Car A and car B start moving simultaneously in the same direction along the line joining them. They are moving the same direction. Okay. Car A moves with constant acceleration. Car B moves with constant velocity. One is increasing the speed, other is going with constant speed. Okay. Time 0, car A is 10 meters behind car A. Find a time when the car A overtakes car B. Okay. Let's try to understand this question. Car A is 10 meters behind car B. This is your car A. Car A moves with constant acceleration. So what happens is, if you just look at car number A, it was at rest and there is a gap of 10 meters. If you compare it with where right now your car number B is, where your car number B is. This car number B is moving with a constant velocity of how much? 1 meter per second, and this is given to be constant. So it keeps on moving with that same velocity of 1 meters per second. Whereas car number A has some acceleration and eventually it will catch up over here somewhere. Maybe it overtakes. So there is some kind of acceleration. How much is the acceleration? 4 meters per second square. Question is, when does it overtake? When does it overtake? That is the question. I feel you can do this question with complete knowledge of relative motion alone. Think about it. What and all is given to you relatively? Think about it. What and all is given to you relatively? Let's try to see either from A's frame or B's frame. Either one will do. Say, for example, I see it from the A's frame. Say, for example, I see everything from A's perspective. So what is the initial velocity of B with respect to A? Initial velocity of B minus initial velocity of A. Velocity of B initially is 1. Of A, it is at rest. Hence, it is just 1 meters per second. That is initial velocity of B with respect to A. What is acceleration of B with respect to A? It is acceleration of B minus acceleration of A. B has no acceleration. It is constant velocity. A has an acceleration of 4. So you put 4. Hence, the answer is minus 4 meters per second square. Acceleration of B with respect to A. I think there is one more thing, and that is displacement of B with respect to A. Can you point it out to me in the chat box? You cannot calculate it, but it is very direct. I mean, there is no point calculating it otherwise. Very, very direct. Think logically. Think logically. What is the displacement of B with respect to A? I am car number A. B is ahead of me. Both start moving. Car number B appears too. Car number B, which is ahead of me, comes closer because I am moving fast. I am accelerating. And finally, I overtake it. So in this entire duration, as an observer sitting in A, when I look at B, B is coming towards me. How much? It's coming negatively because it is coming like this, left side. It has moved 10 meters. It has moved 10 meters relative to A. If A was the observer, B will move exactly that gap which is there between A, B and A. Yes, so the answer for this is minus 10 meters. A lot of students miss that negative sign, or they make a mistake in the magnitude. Now, since I know displacement, acceleration and velocity, and I have to find the time, the only suitable equation is S is ut plus half at square. What is displacement? Minus 10. What is velocity? Well, that's 1 into t plus half into acceleration is nothing but negative 4 into basically t square, right? Okay, so just rearrange the equation. 2 and minus 4 will make it minus 2. Bring it on the other side. It will become 2t square. Bring this also on the other side. It will become minus t. And this minus 10 is as it is. This is equal to 0. This is equal to 0. Wow, this is a quadratic equation now. This is just a quadratic equation. But don't we know how to solve the quadratic equation? Of course we know. So time will be, my dear students, minus b, which is nothing but minus of minus 1, which is making it plus 1, plus or minus a root of divided by b square. B square is 1 square minus into a into C. C is minus 10, so it will become plus 10 over here. The whole thing divided by basically 2 times of divided by 2 times A. Very good. Sir, by the time car reaches B, won't B be more ahead? Exactly, Nikhil. Like I've shown, B will be more ahead. But A has to cover that extra distance. Think about it. Whatever B covers, that distance A will cover. Apart from that, extra 10 meters has to be covered by A. So the relative distance which B or A has to cover is that 10 meters. So the same part you forget. B also moves X, A also moves X, but plus 10. So that 10 meters becomes the relative displacement. Everybody with me? Understood? Yeah, 4 2s are 8 plus, sorry, into 10, 80, 81. So time will just become 1 plus minus root 81 is basically 9 divided by 4. So this one answer will be 1 plus 9 is 10 by 4, which is over here. And the other answer will be 1 minus 9, which is minus 8 by 4. But we all know time can't be negative, not valid. Not valid because it is a negative answer. So the only suitable answer that I can choose is this one. So 10 by 4, which is basically 5 by 2 seconds. So 5 by 2 seconds is the answer, which is 2.5 seconds. Yes, perfect. Awesome. Clear, Nikhil? Clear, Saurav? Very good. Saurav, you get the answer. Very good. Awesome. Let me know, guys, if you understood this particular question clearly. Okay, the main crux of the problem was to get these three variables: displacement, acceleration, and velocity. Only then the signs will be fitting perfectly, else you will get some weird answer. Sometimes you might even get no roots. If you miss the signs, you will be confused if you make a mistake in the signs. Moving to the next one. The driver of a train A running at 25, he sees another train B moving in the same direction at the speed of 15. Driver of train A applies the brakes to produce a retardation. What should be the minimum distance between the trains to avoid the accident? Read the question again. Whenever you see two things in same direction, opposite direction, etc., and you can see some accelerations, velocities involved, generally speaking, it will be a question of relative motion. Good evening, Gunjan. How do we solve this? The driver of train A running at 25 sees a train B ahead, same direction, same track, but a lower speed. So let's say this is train A moving with certain speed of 25 meters per second. Okay, 25 meters per second. And how much is the distance? We do not know that distance. Some distance is there. Okay, so this is basically your train B. It's moving at a lower speed of 15 meters per second. Now, the driver of train A is only applying the brakes. Train B is not doing anything. What a weird fellow. He's still going with the same speed, 15 meters per second. So very, very irresponsible fellow. Train number B, constant velocity is going. Anyways, we cannot judge him so much because he's going there. He can't see behind. Obviously, it becomes a moral responsibility of train A's driver to brake and prevent the accident. Now think about it. If you want to prevent the accident, all right, the question is what is the minimum distance between the trains to avoid it? Retardation is also given. I would say as long as A is behind B, A is behind B, and A's velocity does not exceed B's velocity, I will be safe. If both these conditions are met. A is behind B, yes. A is faster than B, oh, it's a problem. A will slowly come closer to B. But even if B is behind A, sorry, A is behind B, and by chance at some time A's velocity becomes, instead of 25, it becomes 14. Think about it. This is 14, B's velocity is 15. The gap between them will increase. You are safe. It's okay. I might be following that train ahead of me, but my speed is less. No issues. Train ahead of me will move faster. So my speed has to be at least lesser than the B's velocity so that I can prevent that collision. In the limiting case, in that critical case, in that very edge scenario, if I'm even able to maintain the same speed, can I still avoid the collision? Yes or no? Think about it and tell me. Imagine this. Yes, Avanishri, you can continue a little bit. I mean, it should not be much of a problem. Mohammad Hassan, the next session will be on capacitors. Think about it. If A has a speed of 15, B also has a speed of 15, will it not be okay? I mean, still I can avoid the collision. It's just like I'm following the train. It's okay. But I will not collide. Even if I just reach just behind the train is in front of me and I am just behind the train. It's okay. As long as I'm maintaining that speed, I will never ever collide. I should just make sure I'm not faster than that train. This concept has to be clear. This concept has to be clear. So, just when A and B come very close, if A's velocity, if A's velocity is decelerated enough to match 15 meters per second, then you have just avoided the collision. Just avoid the collision. You have just avoided the collision, and that extra distance that you have to travel is that x over here. That extra distance which A had to travel, that is that minimum distance which that train A has to maintain from B before it starts braking. Isn't this problem very similar to this question? Look at that, even the diagrams are similar. This is going with constant speed, this is going with acceleration. Instead, here it is going with retardation. That's the only difference, my dear students. There it was overtaking, here it was collision, and the retardation is 1 meter per second square. So it's the same thing, my dear students. Let's do it. If I ask you what is the initial velocity of B with respect to A, B with respect to A, which is UB minus UA. Velocity of B 15, velocity of A 25, so it will be minus 10. Okay. Then if I ask you what is the acceleration of B with respect to A, acceleration of B minus acceleration of A, acceleration of B 0, acceleration of A is -1 because it is towards the left side, so it will be 1 meters per second square. This was meters per second. What is the displacement of B with respect to A? Think about it and carefully answer in the chat box right now. What is the displacement of B with respect to A? Yep. Think carefully. Think carefully. Is it plus D or minus D? B is ahead of me. B comes closer, closer, closer. How much did it move? D. Which side? This side. What is this side? Negative. So hence, should it not be minus D, my dear warriors? Finally, the final velocity of B with respect to A will be velocity of B minus velocity of A, which is 15 minus 15, which is obviously 0. So there is no relative velocity eventually. 15 and 15 both are moving together. They have just avoided the collision. So the answer is 0. Very good. Steel bangles. Oh my God, why such name, man? Now you are in VITB. Oh, nice. Awesome. ECE department. All the best for your freshers party and amazing, amazing life now. After this, the next 4 years, enjoy it, join the clubs, take part in all the competitions, go for internships, make new friends, right? Enjoy the life. Yep, all the best. Really proud to see you, my dear student, and glad you came back to say hello. Hello. Now, what do we do? Let's use kinematic equation. Which kinematic equation? First, second, third, fourth. See, there is no time involved. So I don't think unnecessarily involving V is U plus AT or S is UT plus half AT square is advisable. Rather, we will use the third equation. Hello, Kripa. Third equation is V square is U square plus 2AS. Final velocity 0. Initial velocity, where is it? Minus 10. So minus 10 whole square plus 2 into acceleration. What is it? 1. Displacement S minus D. Okay, minus D. Take it on the other side. So it will become 2d is equal to 10 square, which is 100, minus square is also positive. So d is basically 50 meters. That should be the answer. Let's check it out. Yes, it is 50 meters. It is 50 meters. Got it, everyone? Yes, Saurav, answer is 50 meters. I think you gave it before. No benzene, no nickel. The answer was not 200 or 5, but glad you tried. Current electricity, part 1, Avanishri, is already done. Part 2 will be done after capacitors, where we will be finding equivalent resistances, capacitances, combination, etc. Okay. Part 1 is already done, current parameters. I hope you have checked out that lecture, Avanishri. Okay. Let's go to another question. Another killer question. Where is it? Wow, JEE advanced question, guys. And what does it say? There is a rocket moving in gravity-free space with a constant acceleration. Just look at it. And the length of the chamber of that rocket is 4 meters. And there is a ball thrown from the left side in the positive direction with 0.3 speed. Another ball thrown in the negative direction with 0.2 speed. And the time in seconds when the balls hit each other. If you can give the answer, I would be really, really proud. I'll just give you 30 seconds. Like, sir, this is J advanced question and you are giving me 30 seconds. What is wrong with you? But let me tell you, I think we can solve this question orally. You're like, what? Really? The answer is yes. Laws of motion, Himesh, Khatri. After this, capacitors, then we'll have one more class on the equivalent combination and all of that. And then after that, I think we'll do laws of motion. Okay, that is the flow. Cool. So, what do you think, my dear students, is the answer? Guys, these speeds are already mentioned with respect to the rocket. So, if this is ball A, if this is ball B, and this is the rocket, I know the velocity of ball A with respect to the rocket is 0.3. Velocity of ball B with respect to the rocket is minus 0.2. So velocity of A with respect to B will be velocity of A with respect to R minus velocity of B with respect to R. Remember, the frame has to be the same. R over here and R over here, perfectly fine, nothing wrong. This is 0.3 and this is 0.2. So this will become just 0.5 meters per second. That is the relative velocity. The relative distance is 4. So using the concept, the relative distance upon time is your relative speed. So distance relative is 4, time do not know, relative speed is basically 0.5. So what will be the time? Time will be 4 divided by 0.5. 0.5 is 1 by 2, so it will become 8 seconds. So that is the answer. Time is 8 seconds. Yes, that is correct. Done and dusted. Hello, Priyaji. Yeah, Himesh, next month, sorry, first week, yes, maximum. Yeah, yes, Himesh, expect around that time. Okay. So like you can see, we are doing all the lectures in detail, 11th and 12th standard in this ROAR series. Okay. And let me also remind you that as you are watching these classes, where is it? Where am I? Relative motion. Yep. So what is ClickUp? ClickUp is an all. Oops. Please don't shout. Okay. Yeah. So understand that I have also kept, where is it? Jungle Book link right over here. Click here to join the Jungle Book. This link is there. And this link basically has all the lectures which have been conducted before this. Okay. For all the subjects, by the way, with their YouTube link, their notes, as well as the DPPs. Okay. So you can see right over here. All right. By the way, some of you are asking, sir, motion in 1D part 1 and part 2 separate DPPs. No, guys, it's one single DPP only. Obviously, it was one lecture or one topic which was just divided into two parts. So that is why you can see the DPP is the same, because it was just divided into two parts. So same thing with the ray optics also. One DPP will only come, which will involve all the questions from all the things. Okay. So I have kept up all the lecture PDFs, everything right over here. Okay. I think Gauss's law also was done. I think Gauss law is missing. Okay, I'll just add Gauss law. Maybe Gauss law was missing, so I'll just add Gauss law as soon as this session is done. Cool. Okay, moving on to the next question. Okay, so let me show you one interesting question, which is very probable that it can be asked. Imagine there is a ball A which is thrown down with some speed of maybe, I don't know, maybe 3 meters per second. Okay. And then there is another ball over here which is probably thrown like this. Okay. With a speed of, let's say, 12 meters per second. Okay. Like this, or maybe say 22 meters per second. 22 meters per second. They are one below each other, and there is a gap between them. There is a gap between them, okay, of let's say 50 meters. 50 meters. From the top, you're throwing a ball down. From the bottom, you're throwing a ball up. Both of them will collide somewhere. The question is, what is the time of collision? What is the time of collision? This is also a very common question. Now, in these questions, what usually people do is they assume that this ball travels x, so this ball will travel 50 minus x. They write equation of kinematics for this, equation of kinematics for this, solve it for x, then solve it for time, blah, blah, blah. Too long, guys. Don't do it like that. Rather, I would suggest you one simple trick in these kind of questions. What is the acceleration of ball A? What is the acceleration of ball A? Acceleration, not velocity. Everything and anything dropped on the surface of Earth falls down with the same acceleration, sir, minus g. Or basically, I can just say minus g because it's going down. What is the acceleration of B? Sir, whether it is going up or going down doesn't matter. Anything and everything always accelerates by the same amount, sir. So the answer is still minus g. So that means, what is the acceleration of A with respect to B? Well, acceleration of A minus acceleration of B, both are same. So answer is 0 meters per second square. Answer is 0 meters per second square. Correct? Agree with this? Awesome. Now, think about it. Think about it. If acceleration is 0, what can you comment about relative velocity of A with respect to B? Like, sir, acceleration is 0, velocity will be 0. No. If acceleration is 0, that means velocity is not changing. It is not accelerating. Velocity is not changing. Velocity is constant. So this relative velocity is a constant. But what is this? We know by definition it is VA minus VB. Oh, I know this value. Both are opposite, guys. Both are opposite. So if both velocities are opposite, opposite speeds means you add them. That's it. So it will just be 22 plus 3, which is 25 meters per second, is the relative speed, which is constant, which is basically constant. Now it becomes a very laddu question. Now it becomes a very laddu question. So if you consider B to be at rest and you go 50 meters away, you are just seeing another ball labeled A traveling towards it with a speed of 25 meters per second. What is the time to collide? Time is distance divided by speed. Distance is 50, speed is 25. So the answer is 2 seconds. Answer is 2 seconds. So that's how direct these questions are. Very good, Saurav, Nikhil. Yep, correct. Can we do this for projectile also? Everything, anything and everything. Okay, anything and everything. Like for example, there is this beautiful question where there is a gun which is aimed, there is this gun which is aimed directly at this monkey which is hanging from a tree. This monkey which is hanging from a tree. Now what happens is at time 0, the gun shoots the bullet. At time 0, the gun shoots the bullet. And at the same time, because the sound reaches really quick and there is a flash, the monkey gets scared. See, the gun is aimed at the monkey. Gun is aimed at the monkey. The monkey gets scared and the monkey basically drops. at t is equal to 0. So the monkey falls down. Now, you might wonder, what kind of a foolish person is this? I mean, this Pandu who was aiming the gun didn't even have this much of brains that if you are aiming the gun to shoot the monkey, you should shoot it little bit up. Only then it will hit the monkey. Obviously, if you aim directly at the monkey, what will happen? The actual path taken by the bullet will be something like this, isn't it? The actual path taken by this will be like a projectile motion. This will be like your projectile motion. Is that right? So actually speaking, there is a difference of this much where, the bullet will miss the monkey by this much amount. Only because he miscalculated. That person missed my class in the road series. So this person technically should have aimed like this. This becomes like your inclined plane projectile problem, and then the bullet would have hit the monkey. But they say when luck is on your side, then the whole universe conspires to prove you right? So when the luck is on your side, the whole universe and probably even physics will conspire to help you to, make you win. Now this monkey left his hands and he is falling down, right? And there is a chance now that because the monkey fell down and because of this guy's miscalculation, either the monkey goes first, then the bullet goes, or the bullet goes first, then the monkey falls, or both of them get hit by each other. Now, tell me one thing, guys. If you ask me what is the acceleration of the monkey with respect to the bullet, acceleration of the monkey with respect to the bullet, the answer will be, sir, it is g bar minus g bar, which is basically 0. It is basically a null vector. It is basically a null vector. So there is no relative acceleration. There is no relative acceleration between the monkey and the bullet. Sir, then the velocity of the monkey with respect to the bullet, sir, it will be a constant. It will be a constant. Oh, interesting. This is interesting. This is the velocity relatively is constant, which just means, imagine, oops, I created another slide mistake, which means imagine a gravity free zone, zero acceleration. Okay, zero acceleration. The bullet which was fired. See, why am I saying zero acceleration? Because zero relative acceleration, right? Zero relative meters per second square is the acceleration. So just imagine a zone of 0 meters per second square, gravity free. This bullet is fired in such a zone. How will it go? It will obviously go in a straight line because there is no gravity. What will the monkey do? What will that monkey do? Think about it. In that gravity free zone, zero acceleration, even if that monkey leaves the hand, he will stay there. So in that zone, the monkey stays there as it is. So what will happen in such a scenario? The bullet will go and hit the monkey. Imagine a gravity free space, no gravity at all, zero gravity. You aim at the monkey, bullet, zoop, monkey leaves the hand, nothing happens, the monkey doesn't fall down, the monkey gets hit by the bullet in that zero acceleration zone, no relative acceleration. Same thing will happen here also. So you will see the monkey will get hit 100%. So there will be a collision. Right over here. So you will have to think of a relative frame which is also falling down with G, In that frame, that monkey is at rest. So think of a frame of reference of the monkey. From that frame, the bullet appears to go with a constant velocity, so it will always get hit. That's interesting. Yes. Is that clear? What an interesting question. If you take a frame of reference of the free falling frame, the monkey will be at rest in that free falling frame, which is accelerating with G. The monkey is at rest. the bullet will just go a straight line motion, and you will always see the bullet coming towards you in that free falling frame. That's what is going to happen. So it's even valid in 2 dimension, 1 dimension, every dimension, 3 dimension also. Okay, so that was your foundation level relative motion concept. Now there is one more interesting question of relative motion which was asked in JEE, and I feel that we should do it. I think I had kept it somewhere. Oh, it's in 2 dimensions. So we'll start with the easy questions of 2D, and then we'll go to the more difficult ones. Here is the first 2D question. Look at this. A car has an acceleration of 2 due east and car B has an acceleration of 4 due north. What is the acceleration of car B with respect to car A? What will you do in this particular question, my dear students? Yep. Wow, you loved the physics shown in the movie. Almost all Christopher Nolan movies, guys, they have amazing physics, isn't it? Game Slayer. Okay, so what do? Car A has an acceleration of 2 east, B has acceleration not. What is the acceleration? What is the acceleration of car B with respect to car A? So it will be acceleration of B minus acceleration of A. Is that right? What is the acceleration of B? Acceleration of B is 4 but due north, so j cap, minus acceleration of A is 2 east, so plus I cap. So minus 2 I cap plus 4 j cap is the answer. Acceleration of B with respect to A. That's it. If you talk about the magnitude of this, it will be nothing but 2 square plus 4 square. 16 plus 4 is 20. So it will be root of 20, which is 2 root 5. If you draw it diagrammatically, minus 2 I cap plus 4 j cap, it will be something like this. So 2 root 5 meters per second. This is going to be like this. This is going to be 2 units. This is going to be 4 units. If you mark the angle over here, theta, so that tan of theta will be opposite by hypotenuse, which is half. So that angle will be tan inverse of half. So this is the acceleration magnitude, and that is the angle which it makes with the north direction. I think that is correct. North of west or west of north, it depends. So if you measure the angle this way, if I call that angle as, let's say, phi, then tan phi will be 4 by 2, which is 2. So then phi will be basically tan inverse of 2. So you need to check the options whether it is mentioned with the west direction or with the north direction. How is the angle measured? Accordingly, both answers will be correct. Next one. Ship is steaming towards east. Woman runs across the deck relative in a direction north. Calculate the velocity of the woman relative to the sea. Come on. Everyone, figure this question out. Ship, woman question. What do we do in this particular case? Let's see. Ship is going due east at 12. So velocity of the ship with respect to the ocean or the sea will be 12 I cap because it is towards the east. Velocity of the woman with respect to the ship is north. How much? 5. So 5 j cap. I think I told you the chain rule. I think we can just use that over here. So check this out. Velocity of the woman with respect to the ocean will be velocity of the woman with respect to the sea plus velocity of the ship, my bad, not sea. Velocity of woman with respect to the ship plus velocity of the ship with respect to the ocean. I think this is correct. WO, so W is the start, O is the end, S is in between. You can extend this chain as long as you want. VWS is nothing but 5 J cap. VSO is given over here is 12 I cap. So it is actually 12 I cap plus 5 J cap. So if you ask me what is the magnitude of this velocity of the woman with respect to the ocean's magnitude, it will be root of 12 square plus 5 square, which is 144 plus 25, which is 169. So it will be 13 meters per second. So 12i plus 5j, right? So 12i plus 5j will be something like this. This will be the velocity of the woman with respect to the ocean, which will be 13 meters per second. It will be 12 units here, 12 units here, and 5 units over here. That is what it will be. Cool? Yep, everyone. Sir, you finished my 12th in 2022, 2020, but I made a JEE Mains first attempt in January. Am I eligible to write JEE Mains 2026? Surya, that's 2 years of drop. Yes, you can. You can. Yeah, that will be the last attempt. No, if you have passed in 2023, then you can't. 2026 is not allowed. Maximum 2 drops. Remember that. Yes. Moving on. Two ships are 10 kilometers apart on a line from south to north. The one farther north is moving towards the west and the other moving towards the north at 40, the distance of the closest approach. Now, the distance of closest approach questions are also very, very common. So, let's do this. Let's first draw the diagram to understand. Two ships are 10 kilometers apart from a line south to north. One is farther north, is moving towards the west. The one which is in the north is moving towards the west. West is left side with what speed? 40 kilometers per hour. Let's say we call that ship number A. Then how much is the separation? 10 kilometers apart. So we think of 10 kilometers distance, something like this. And then you have the other ship over here. The other ship is moving north at 40. Okay, the other ship is moving north at 40 kilometers per hour. Let's say I call that ship number B. Question is the distance of the closest approach. See, I'll tell you what the problem is over here. See, A will continue moving like this. A will continue moving like this towards the west, whereas B, which is over here, will continue moving upwards like this. At some point, obviously, it will cross the intersection also like this. A lot of people think, sir, the closest distance is 0 because they are meeting over here. But understand, when B reaches here, when the ship number B reaches here, A has already moved much ahead. So you need to understand that. So technically, if you see, how it goes is basically, initially, the separation between them was this much. Let me just put it over here. Initially, the separation between them was this much. Then what happened? A moved here, B has gone here. So it is this. Then B has gone here, A has gone here. Then this is here. Okay. Then this is here. Then this is here. Okay. Then this is here. And then this is here. Okay. And then probably this is here. And then after this, this will continue, guys. This journey will continue like this. So these are the distances of separation between them. So I don't know which of these lines is the closest. All right, the distance is continuously changing. That distance which is there relatively is not at all a constant. One of them could be the closest. I don't know which one is this. Maybe this one or this one. I don't know. I'm just chumma guessing. Maybe this one is the closest distance. Who knows? So there might be a line which is probably the closest. This is the closest, maybe. Example. This is just for your understanding. So now, how do you do these kind of questions? The logic for them is, see, if there was a Pandu and there was a bus which is going like this, or if there was a bus which was going like this, then closest distance between the bus and the Pandu will be obtained by drawing a perpendicular on the path of the bus. Drawing a perpendicular on the path of the bus. This is the closest approach. This is the closest approach. And this happens only because this particular Pandu is at rest. Oh, now I got my idea. If Pandu also was moving, bus was also moving, Pandu was moving, bus was moving, then how do you find it? make one of them at rest, you will see the other one going at an angle, drop a perpendicular, that would be the closest distance of approach. So basically bring one of the object at rest. Hello Savaria, did you understand this part? Why you should bring the other thing at rest, my dear students? Why you should bring the other thing at rest? Everybody clear till this point? Awesome. So in this particular question, what I will do, let me find what is the velocity of A with respect to B. So velocity of A with respect to B, which is VA minus VB, will be VA is nothing but minus 40 I cap, VB is nothing but 40 J cap. Perfect. So this is the relative velocity of A with respect to B. Magnitude wise, it is 40 square plus 40 square under the root, which is basically 40 root 2 kilometers per hour. Okay. So now I'm talking about A's velocity with respect to B. So if I make A at rest, sorry, B at rest, my bad. If I keep B at rest, so B is now at rest. How will A appear to me? Moving at minus 40 I cap, minus 40 J cap. That means this is not the correct velocity. Minus 40 is this way, minus 40 J is that way. So the net velocity will be like this, and the ship will continue to go in this particular direction. Perfect. And with what speed? With a speed of 40 root 2 kilometers per hour. Isn't it amazing? This is the direction in which A appears to move with respect to B. So how do you find the closest distance now? Just drop a perpendicular. Just drop perpendicular. So if I drop a perpendicular like this, very nice. This is the closest distance. Oh, amazing. But wait a minute. I just know this is minus 40I minus 40J, which means the components of this would have been equal negatively. This would have been minus 40 I cap. This would have been minus 40 J cap. Isn't it obvious this angle will be nothing but 45 degrees, just like this angle, which also would be 45 degrees. Both the components are equal, so both these angles will be 45 degrees. Now do you see this particular triangle? Which is the triangle that I'm talking about? This triangle, this one. Look at that particular triangle, guys. Look at that particular triangle. This is 90 degree. Okay, this is 45 degree, and this gray distance is basically 10 kilometers. So how much will this be? Guys, you just have to use sine 45. If I use sine 45, which is the opposite side upon the hypotenuse is basically 10. So therefore, sine 45 is 1 by root 2 is d by 10. So therefore, d will be nothing but 10 divided by root 2 kilometers. That is the answer. That's the closest distance of approach, 10 by root 2 kilometers. Is that clear, everyone? Yes, Nikhil, correcto, perfecto. If somebody asks you after how much time will they be closest, after how much time will they be closest, no issues at all. If they ask you the time, I know time is not, but Chuma, I'm solving that question also for you. If somebody asks you the time, what will you do? Same diagram, just look at the other side now. Just look at this side. This is 10, right? Okay. Tell me quickly. Just draw it properly over here. Okay. This was your D. How much is this distance? Come on. How much is this distance? This is 10. This was, we just figured it out, 10 by root 2. If this D is 10 by root 2, how much is this particular distance going to be? That is also going to be 10 by root 2, my dear students, because this angle is 45, this angle is also 45 degree. Both the angles are 45, so the sides will be equal. So now if you just look at this particular part, and if you use if you use distance which is relative upon time is nothing but your relative velocity. This distance being 10 by root 2 divided by time will be the relative velocity. Relative velocity is 40 root 2. Relative velocity is 40 root 2. Root 2 cancels. Time goes on the top. It will become 10 by 40. 0, 0 cancels. It will become 1 by 4, which is basically 0.25 of a second. So within the next quarter of a second, they are the closest. Got it, everyone? Yep. So this is how you find the time. This is how you find that distance. These kind of questions are also very, very common. So the closest distance is 10 by root 2 meters. Now there was another interesting question. I have put it. Yes, this is another interesting question, level 3 question, where you have 3 dogs or 3 particles or 3 mad fellows following each other with the same speed. Imagine this. Dog number A is asked to move with constant speed wherever B is. That's the only ambition and aim in life. No JEE, no NEET, no advanced, no bits, nothing. Dog A has to just move towards dog B. And what does dog B have to do? Exactly the same thing in return, but for C. So B has to go exactly where C is. C has to go where A is. So the path taken will be very, very interesting one. Like you can see over here. What happens is every dog is following the other dog. So if A tries to move towards B, B being here, but at the same time B is moving towards C, at the same time C is moving towards A, C is moving towards A, what will happen? Because B is moving like this, meanwhile A also has to tilt its direction simultaneously. Simultaneously, B also has to tilt its direction because C is going here, and C also has to simultaneously tilt its direction as it moves. Next instant also they will have to do the same thing. Maybe maybe A will go like this because B is going like this. C will go probably like this, following A. B follows C, A follows B, and C follows A. And the next instant, maybe, they go like this goes like this, and this goes like this, and they collide over here finally. And finally, they collide over here. It's a curved path. It's basically a curved path. Everybody is able to visualize this. Rain Man Veda, we are coming to that. Hold on. First, we are doing generic questions, then we'll come to River Boatman and then the person holding the umbrella problem. Okay, we are going to come to that also, Veda. Okay, don't worry. This is a detailed class. We don't skip anything. Okay, we do everything. All the concepts covered in this lecture. In this entire simulation, if it is running in your head, you will realize one more interesting fact is that initially, if there was a equilateral triangle which was formed like so, after some time also you will see another equilateral triangle but which is tilted. After some more time you will see another equilateral triangle but even more tilted. So it's like a equilateral triangle which is trying to hypnotize you by becoming smaller and rotating. Just imagine this. It is very, very psychedelic. Just that equilateral triangle becomes smaller and grows smaller and smaller, and it rotates and it combines, merges into a point. That is the simulation of this entire motion. How many of you were able to visualize this? Put fire emoji in the chat box right now. Now, there is, let me tell you, Karthik, these kind of questions also come for a quadrilateral or for even for hexagon and whatsoever. So there was a question, it's there in HC Verma. I think the last question or the second last question, maybe with a square and then with a hexagon. So the same thing can also happen with a square. Okay, this particle travels here, this particle travels here, this particle travels here. Now there are 4 dogs moving towards each other. So actually their motion will be a curved line. So it will be a curve like this because they are moving towards each other. So after this also you will see it will still form a quadrilateral like so. Okay, it will be a quadrilateral. After some more time, this will go like this, 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 maybe. Okay, just drawing freehand, it will be like this, okay? And this will keep on happening till they meet, till they meet at the same point. This is what is going to happen. This also can happen for a hexagon, by the way. This can also happen for a hexagon. I don't have an hexagon which I can draw readily, but yeah, just imagine this. Okay, even for a hexagon, guys, this can happen. Okay, any n-sided polygon, basically. Okay, it can happen, and you can make general rules for that also. We'll first solve the triangle problem, then we can go to the any n-sided polygon. It's not that difficult. So it's always a triangle, that's one thing. It's always the equilateral triangle, actually, and the speeds are constant, the motion is in a curved path. When do they collide? So I feel because the entire problem is symmetric, whether you talk about A or B or C, or if it's a polygon, it could be D, E, F. So everything, every particle has a symmetrical motion. Yeah, the locations are different, but their motions are very symmetrical. So you can look at anything with respect to anything. I can look at A with respect to B, or C with respect to A, or B with respect to C, or C with respect to B. It doesn't matter. It's all the same. It's all the same because the entire and all the particles, all the dogs, all the objects are moving with the same speed relative to each other. Perfect. So what we can do is, let me show it in the next slide. If I probably make the frame of reference, if I make the frame of reference as B and observe C, if I make the frame of reference as B and observe C, what will I observe at any instant? See, understand the distance will keep on reducing. The distance will keep on reducing. B will also tilt like this. After some time, C will probably come over here. C will come over here. After some more time, probably the frame of reference would have been tilted more, and then C would be here. Doesn't matter, guys, which instant you consider. At any random instant, at any random instant, at any random instant, if I consider B has a velocity, B has a velocity of V, and C has also a velocity of V, which again has two components, So if I break down C's velocity into two components, one like this and one like this being 60 degrees, this would be V cos 60, and this would be V sine of 60 degrees. These are the two components of the velocities. Agree, disagree? These are the two components of the velocities. What is cos and sine component doing? Let's see it separately. If you just look at the cos component, basically the horizontal ones, for B, which is going with speed V right side, C is going left side with a speed of V cos 60. If you consider the vertical component, B does not even have a vertical component. B is at rest. C is just going like this with V sine 60. Because of this perpendicular component, realize this distance is not changing. It is perpendicular. That velocity is not affecting it. It is not affecting this separation. Not affecting this separation. Whereas the cost components, 100% guarantee, guys, the separation is being affected because of that. Their separation was the side length of the triangle, which was basically A. Oh, speed, distance, time. Time is relative speed by the, time is relative distance by the relative speed. What is the relative distance? That's A. What is the relative speed? It is V plus V cos 60, my dear students. So what is cos 60? It is half. So it will be v plus v by 2, which is 3v by 2. So 2 goes on the top. So it will become 2a divided by 3v. That is the answer. 2a divided by 3v. Got it? My question is, what does the path of an object look like when it is in uniform motion? Subhashri, when uniform motion, do you mean uniform accelerated motion? If it is uniform accelerated motion, there are only two things which an object can do. Either it can go in a straight line or it can go in a parabolic path. These are the only two options. Best example, you drop something, it goes like this. You throw something up, it goes up and comes down. Both are straight lines. If you throw it at an angle, it goes in a parabolic path. So these are the only two options for an uniformly accelerated motion. Obviously, now you can do the same thing for quadrilaterals or hexagons, pentagons. For example, if we had to do it for this guy, I would say, okay, if I sit over here, then if I look at this particular object, this is A, let's say this is B, I would notice A is going with velocity V, B is going with velocity V like this, and there is no component of B in the direction of A. Oh, interesting. So in the next step, what I will do, if I just look at the horizontal motion or the motion along the line separating them, motion along the line separating both of them are being separated by distance a, there is only one velocity and that is v. There is no component of b along that line. So hence that time will be distance relative by speed relative, which is a divided by only one speed, which is v. So the answer will be a by v for a square. Answer will be a by v for a square. Similarly, you can do it for a hexagon. Okay, so you try it out. So this is your homework question. This is your homework question. Answer it in the comments. Answer it in the comments. Answer it in the comments. What will be the time for collision? What will be the time for collision? Okay, will you be able to do it, everyone? 100%, I think you can do it. Very nice. Shall we now go to the next concept of riverboat problems, riverman problems, and then the rainman problems also. Ready for it? Okay. Awesome. Okay. So I hope you have understood everything till now. Okay. And in a very different manner, we have done all varieties of questions also. By the way, the number of questions in relative motion is limitless. You can keep solving and you'll always find something interesting which comes up in the relative motion. So that's why it's a very interesting chapter. Okay, so river boatman problems. So the river boat problems, basically I'll tell you these kind of questions, whether it is a river or whether it is wind versus whether it is a boat or whether it is a swimmer or whether it is an aeroplane, they are all the same things. They are all the same things. Person swimming inside the river is same as a boat, motorboat going inside the river, or air, inside air or inside the wind, aeroplane is going. Okay, it's one and the same thing. This is also uh, uh, going to see that very similar looking formulas. Now we'll use similar terminologies everywhere so that we are not confused. So the velocity of the wind, velocity of the river, let's use the symbol. Let's say, for example, W. Let's use W. Water flow, wind flow, W. For the aeroplane speed, swimmer speed, boat speed, we'll use speed U. What is this with respect to? This is the velocity with respect to the bank, or basically the ground, or basically the ground, or basically the fixed things. Okay, the bank, the airport, the port, the ground, basically the ground frame. The velocity of the wind or the velocity of the river flow is also with respect to the bank or with respect to basically the ground frame of reference. The last speed which comes up is this v velocity, which is, oh sorry, I made a small blunder over here. Let's not keep it with respect to the ground, guys. Let's keep it with respect to the wind or basically the river or basically the river or basically the water. We'll keep this u with respect to the river or the water. So then our final speed v will be with respect to the ground or basically the bank or basically the bank. So we have w, which is wind speed, water speed, etc. Then we have the swimmer speed with respect to the water or the aeroplane speed with respect to the wind. And lastly, this is the velocity actually with respect to the ground or the bank. So W, U and V. Till this point, is it clear? Veda, motion under gravity already done. Motion in 1D, motion in 2D already done. Please check my old playlist. I mean, old as in just done, recently done, right over here. If you have missed the class, open the Jungle Book. You can see motion in 1D, motion in 2D already done. It's there in the Jungle Book. Jungle Book is the one single sheet maintaining everything. The YouTube link, PDF notes, DPPs, everything is there over here. Okay, good. So just to give an example over here, imagine the wind is blowing like this. Imagine the wind is blowing like this, or the water is flowing W like this. The swimmer with respect to the water or the aeroplane with respect to the wind is maybe going like this, or maybe going like this. Doesn't matter. Then the total velocity of the swimmer or the boat or the aeroplane will incorporate both the things, the wind velocity also and what the swimmer or the boat or the aeroplane is doing with respect to the wind. So the resultant velocity will be basically v. So you will always see that v bar technically is nothing but your u bar is nothing but your u bar plus your w bar. This is a very, very important or significant relationship. Always this holds true. Always and always this holds true. Keep this in mind. Everyone? Everyone clear till this point? Everyone clear till this point? So let me give an example for this. Imagine we have an aeroplane which is going like this with a speed of 40 meters per second, example, or let's say 400 meters per second, let it be large. And say, for example, the wind happens to blow like this towards the east. The wind is blowing like this towards the east with a speed of 300 meters per second. The plane is pointing somewhere, but the wind is blowing here. So what will happen is the plane will end up going at an angle. The plane will end up going somewhere over here. And that velocity will be nothing but your wind velocity plus the plane's velocity with respect to the wind. The plane's velocity with respect to the wind, which is nothing but 400 j cap. And our wind velocity would be nothing but 300 I cap. So 300 I cap plus 400 J cap will be the velocity of the plane relative to the ground. So this velocity, this is obviously with respect to the ground frame. If you ask me how much is the magnitude, the answer will be nothing but take the root of 300 square plus 400 square is a Pythagorean triplet, simply put 3, 4, 5. So it will be nothing but 500 meters per second. So this will be the speed of the plane as seen from the ground, which will move at 500 meters per second. Clear till this point? Okay. The wind will take it here like this. The plane is trying to move ahead like that in the north. So total velocity will be at an angle in this particular direction. Cool. Now the same concept you can also apply for the river, boat, man, swimmer problems. So we'll see that as well. So usually what happens is that you will be given a river. These will be the banks, and you will be told that listen, the water is flowing like this, or the other way around, doesn't matter, with some speed. There will be a person standing on one of the banks, maybe here or somewhere, and this person will probably go like this or like this, doesn't matter. Maybe, for example, for now, the person is going like this with some speed. Now, once he jumps into the water, he tries to swim like that. The wind or the water will try to pull him in this direction. So his resultant velocity will be like this. This will be his resultant velocity, and he will end up going like this in a straight line path. So this will be a straight line path somewhere over here. This will be how his motion would be. And he will end up reaching over here. He will reach on this side, and he has basically started from this side. He has started from this side. Everybody clear till this point? If it changes the angle, if the W changes or U changes, obviously V, where he reaches, how long does it take to reach, everything will change accordingly. Now, there are some critical aspects over here also. If you go directly to the opposite point, this is directly the point on the opposite side. Directly the point on the opposite side. This distance that you see, that is called as the drift. How far from the opposite edge you are reaching here, this is basically going to be called as the drift. This is basically going to be called as the drift which the person encounters. There is some drift. Also, you take some time to cross the river. Now, how much is that time? How much is the drift can be calculated very simply. Tell me one thing. If I turn the direction, obviously keeping the river velocity the same, my resultant velocity will also change. I will probably end up reaching here, or if I swim like this, still, river will be moving like this, and my resultant will be like this. I will end up going like that. Or I swim only at an angle in this particular direction. The river will pull me like this, and my resultant will be much longer like this. Okay. In all the cases, what you will see, the drifts are different. The time taken to cross will also be different. Think and tell me, will the river velocity in any way affect the time taken to cross or not? If the river speed increases, imagine river speed is very fast. You might have seen videos these days in monsoon, very fast moving rivers. We think it will take more time to cross the river, maintaining the same angle, maintaining the same speed. Whether the angle will be given to you. Yes, Vishal, like I said, I will be putting up the Gauss law notes. I think that was missing. I'll just put it up. Don't worry. Yes. What do you think? It will not be dependent. How is it dependent? Because river velocity is horizontal. You are crossing from this side to this side. Remember, this is the direction of the crossing. Always you are crossing in this direction. You are trying to cross. When I say you are crossing the river, you are crossing the river in this particular direction. Whether you reach here or here or here or here, doesn't matter. Crossing is this side. So when I say time to cross, when I say time taken to cross, what do you think will it depend on? It will just depend on the vertical velocity. It will just depend on the vertical component of the velocity, right? It will just depend on the vertical Vy component of the velocity. Time is distance by speed. Time is distance by speed. Let's say that distance between the banks is d. The distance between the banks is d. So it will be d by Vd. But also let me remind you, the vertical component of the resultant velocity is also the vertical component of the u velocity of the swimmer. It is the same thing. There is no difference at all. There is no difference at all because w did not contribute only in the vertical velocity. Y component was not contributed. So uy is the wy. So whatever is the vertical component of v is also the vertical component of u. This and this are the same. Vertical components are exactly the same, guys. Everybody clear to this point? Everybody understood? The components can be found if the angles are given. We will see the questions where angles are given. Don't worry. Next question. If I ask you what is the drift? If I ask you what is the drift, what will your answer be? What will your answer be? Think and tell me. It will depend on, forget u, forget w. Resultant velocity is like this. Whatever is the x velocity of the resultant velocity, that x velocity upon, into how much time I spend in the river. Horizontal velocity into how much time I spend in the river. That's it. So it will be just Vx multiplied by your time taken to cross. Multiplied by your time taken to cross. That's going to be the drift velocity. So remember all these things. So your Vy will be like this. Vx will be like this. Uy will be the same as Vy. Ux can have any value, that's okay. Nothing wrong with that. Nothing wrong with that. Keep that in mind. Okay, so this is the main general equation. Now there are two, or rather I would say three specific categories in this. Three specific categories. The first category is to cross in the shortest time, cross in minimum time. When you want to cross it in the minimum time, think about it, you will use your maximum velocity to cross the river. You will use your maximum velocity to cross the river. So you will be directing yourself like this because you want to cross the river. So you'll use your maximum velocity here. You don't want to waste any component in the horizontal direction. So that is how you will try to cross it. Yes, the river might try to bring you like this and you will end up moving like this and you will encounter some drift. There is no issue at all like that. Yes, there will be certain drift, no problem, but you will cross it in the least possible time. So the strokes of the swimmer or the direction of the boat pointing towards will be perpendicular, will be exactly perpendicular to the flow of the river, will be perpendicular to the flow of the river. That's when you take minimum time to cross. That's when you take the minimum time to cross. Here, the time taken to cross can be seen very, very easily. The vertical component, how much will it be? Distance by your vertical component. Think about it. The vertical component will be u itself because you can see the vertical component of v will be u itself. So hence I can just say it will be d divided by the complete velocity u. And if you talk about the drift, my dear students, the horizontal velocity vy, into the time taken to cross, how much is that x component of the velocity? It will be w. X component of the velocity will be just w, guys. So this vy will be just w, and the time taken to cross, right from here we can bring it over here. So it will be just d divided by u. Okay, so that is your drift. That is your drift, guys. That is your drift. Vy will be W. You can see it right over here. You can see it right over here, my dear students. So V will have two components. One will be Vx, another one will be Vy. The Vy will be U, you can see that, and the Vx will be exactly the W. That's what it is. That's how I can replace it. Clear till this point? Can we go ahead? Everybody fine till this point? This is the first case. What is the second case? There are two sub cases in that. No drift at all. And then the third case, which is also the sub case for the second one, is minimum drift. Why minimum drift versus no drift? See, these are the banks. If by chance my speed of swimming is higher than the river speed, then I can align myself such that the river speed is over here and my speed is over here, so that my resultant velocity is like this, and I end up reaching exactly the opposite side. So here there is no drift at all. I am reaching exactly the opposite side. This is only possible. This is only possible if the speed of the swimmer u is more than basically the speed of the river. Only and only then this is possible. Because you can see hypotenuse has to be longer than the other side, the perpendicular sides. So u, if it is more than w, then you can use some velocity of the swimmer to compensate the river flow. So that velocity u, a part of it will compensate the river velocity, and the rest of it will be used for crossing. But imagine a scenario where your u is basically less than w. Then what will happen when u is basically less than w? No matter how hard you try, because this is small and the river speed is big, you will never be able to cancel out the river velocity. So you will end up drifting somewhere. But you can minimize that drift. You can minimize that drift by choosing an appropriate angle. You can minimize that drift by choosing an appropriate angle. So no matter what you do, because this u is little bit small as compared to the river velocity, no matter what you do, you will never get zero drift. You will always get some drift. You will always get some drift, but we can minimize that drift. But we can minimize that particular drift. So you can have minimum drift by choosing the right angle. I'll come to that in a bit. So when you want zero drift, no drift at all, here there is zero drift. It's very obvious that your your swimming velocity will make some angle theta, and you can clearly see that sine of theta will be opposite side by hypotenuse. So opposite side being W. That is the angle at which you will swim with respect to the perpendicular, so that you reach with zero drift. Vx is equal to 0 is possible. Exactly. Over here, what is the case? The Vx value is 0. What is Vy? Vy is nothing but u cos theta. Vy is nothing but u cos theta. I hope you can see that. Vy is u's cos theta component. Everyone, you can see that very, very clearly. So this would be u cos, u sine theta. This would be u sine theta. This would be u cos theta. And of course, this would be your v. And the river velocity will be exactly opposite. The river velocity will be exactly opposite. So the u sine theta component is cancelling w. So the w will be cancelled by your u sine theta. That is exactly what is happening. Also, you can see over here sine theta is w by u. Sine theta is w divided by u. Exactly what is happening. Awesome. You can also find the time taken to cross. That's not difficult at all. Again, you can see that. So if you want to find the time taken to cross, which is vertical velocity and a distance related. So distance divided by your Vy, distance divided by your Vy. So over here, the distance being d only, Vy is just nothing but your u cos theta, is nothing but your u cos theta. That's it. Okay, as simple as that. Clear, my dear students? Awesome, awesome. Now, what about minimum drift? This comes via derivatives, maxima, minima concept. I'll just skip that part. I'll just tell you what the final answer looks like. So, here, if you measure this particular angle, let's say theta. So, u will have two components. One will be u sine theta over here. The other component will be u cos theta over here. The river velocity will be much higher than that. So that W will be here and the resultant will be like this. So you will have some X component. You will also have some Y component. You will also have some Y component. This is how the diagram will look like. Okay. The river velocity is much larger than the velocity of the swimmer. So you will have two components, u sine theta here, u cos theta on the vertical side. Velocity will have two components, Vx and Vy. This is how it will look. Okay. So I'll tell you what is the angle for which the drift is minimum. See here, sine theta was W by U. W is small, U is big. Sine theta is anyways less than 1. Makes sense. Sine theta is always less than 1. Still keep sine theta less than 1. How? Just instead of W by U, make it U by W. Make it U by W. That's it. That is still going to keep sine theta less than 1. That is the answer, guys. As simple as that. Okay. So, as simple as that, that is the answer for minimum drift. Just keep the numerator smaller than the denominator. Okay. Very, very easy to remember. If you want to again find the time taken to cross, distance by speed over here. So, it will be nothing but distance by Vy. And over here, what is Vy? Vy is nothing but u cos theta. It is nothing but u cos theta. If you are talking about the drift, my dear warriors, if you are talking about the drift, it will be Vx component, Vx multiplied by the time taken to cross. Now, what is Vx? Vx is W minus u sine theta. You can see that right over here. It is Vx is this big minus this small thing. So it is W minus your u sine theta. W minus your u sine theta, and your time taken to cross was your d divided by u cos theta. Do you have to remember these formulas? No, of course. I'm just showing you how to apply the same logic again and again. This was the generic formula. Where is it? This was the generic formula. If you know how this works, whether it is this problem or this problem or this problem, you know how to solve it. Okay. Thank you, football log. Shall we now do some questions? My dear students? Okay. Let's do then. Let's do. Coming up on your screen. Okay. I have put up all the theory pointers also for all of you. Oops. Okay. What is it? The speed of the swimmer is given. Speed of the swimmer makes his strokes normal to the flow of the river. He reaches a point 750 meters down the stream. The speed of the river water is how much? Okay. Let's draw and think how it will look like. Come on, my dear students. How will it look like? Speed of the swimmer is given. Swimmer makes his strokes normal to the flow. Normal to the flow means perpendicular. How much is the speed? 4. And the river speed not mentioned. I'll just assume it as W. So the resultant velocity will be like this. You will end up reaching somewhere over here, whereas the opposite side would have been here. This side is 1 kilometer. This side is 1 kilometer. and he ends up reaching somewhere over here. This is 750 meters, which is basically 0.75 kilometers. Question is, what is the river velocity? Okay. First of all, because width is given and the speed of the swimmer is known, I think I can easily find the time taken to cross. The time taken to cross is the distance between the banks upon the vertical velocity. Uh, Distance is 1. Vertical velocity is nothing but 4. So it is 1 by 4 of an hour. So the time taken to cross is 1/4 of an hour, basically 15 minutes. Next, for the drift, what is the formula? For the drift, the formula is, it is the horizontal velocity into the time taken to cross. What is the horizontal velocity? The horizontal velocity is W itself. Time taken to cross is 1 by 4. The drift is basically 0.75. Got it? So it's just about whether you are able to resolve the vectors. Have you understood the general logic of solving the question? This general logic, whatever I gave you over here, if you are able to understand this, any question you will be able to solve, guys. Okay. So what is W going to be? It is going to be 4 times of 0.75. So how much will W be? How much will W be? It will be basically 3 kilometers per hour. That should be the answer. Yes, the answer is 3. Very straightforward. Okay, great. We'll be doing more problem solvings. Don't worry, Veda, because like I said, relative motion is an endless topic. You solve every question, you will feel always there is a question which you have not solved. So we'll be having problem solving classes also. Like I said, PYQ sessions, etc. are there, which are lined up. So in PYQ problem solving sessions, we'll have it. Okay, don't worry. Width of a river is given. Speed of the river is given. Rowing velocity is also given. Okay. Angle is also given. Find the time, drift, etc. Yeah, boatman, everything. Okay. So let's try to find it. This is our river banks. 37 degrees from the direction of the river current, 5 meters per second. So if my speed is 5 meters per second, making angle 37, I will have two components. One component like this, which is 5 cos 37, and the other component will be like this, which is 5 sine 37. Sine 37 is 3 by 5, so answer will be 3 meters per second vertical, and cos 37 is 4 by 5, 5 cancels, so it will be 4 meters per second. I'm just resolving it into components because I know I will need it. River velocity is like this. How much is it? River velocity is 2 meters per second. So my resultant will be this one. This will be my resultant. Think about it, right? This whole thing will be my resultant. Now, if you look at the resultant velocity, the vertical height of the resultant velocity is simple. It is still going to be 3 only. It is still going to be 3. But the horizontal part of that green line will be this plus this much being 4, this much being 4, and the remaining part being 2, and the remaining part being just 2. So strictly speaking, from here, I see that Vx is 4 plus 2, which is 6, and Vy is just 3. Vy is just 3 and Vx is basically 6. That's what is the complete sense of the problem. Did you understand this vector resolution and how we have taken it up? Now to find the time taken to cross. In order to find the time taken to cross, I just need to take the distance by Vy. Distance, how much is the width? 30, is it? Okay. Divided by Vy. Vy is 3. So answer is 10 seconds. Perfect. Next is the drift question. So the drift will be Vx into the time taken to cross. Vx is basically 6, time taken to cross is 10. So answer is 60 meters. So let's check it out. Where is it? Yeah, 10 seconds and 60 meters. Perfect, guys. That is correct. Perfect. 10 seconds and 60 meters. Got it, guys? How we resolve the velocities? Because I know x and y, solving it separately will be better. Much, much better. Cool. Shall we go to the next question coming up on your screen? Here it is. What does it say? River is flowing from west to east. Man is on the south bank, capable of swimming in still water. Wants to cross in the shortest time. Which direction should he swim? Okay. So this is how the river is. The river is going from which side? West to east side. Okay, the river is going like this. This is the east side. This is the west side. The person is on the south bank. So which direction should he swim so that he reaches in the shortest time? Shortest time means you'll use all your velocity to cross. Cross means like this. So all your velocity will be used like this. So you will be like this, perpendicular. So which direction is it pointing towards? North direction. So hence the answer should be north. Yes, due north is the correct answer. Straightforward. Yep. Everyone clear? Shall we go ahead to the next question coming up on your screen? Let's do this. What does it say? Man can swim with a speed of 4. How long does it take to cross a river this much wide, flowing steadily at 3, and he makes his strokes normal to the river? How far down does he go when he reaches the other bank? Okay. Again, he's basically crossing it in the shortest time because he's going perpendicular to the flow. His velocity is 4. His velocity is basically 4. River velocity is 3. River velocity is basically 3. So his resultant V will be root of 3 square plus 4 square, which is 5 meters per second. So we'll end up going here. And the width of the river is 1 kilometer, basically 1000 meters. Now, if you want to find the time taken to cross, which is distance by Vy, distance is 1000. Vertical component of the velocity is 4. Vertical component of the velocity is 4. So answer is basically 250 seconds. That is the first answer. If you ask me how much is the drift, it is horizontal velocity into the time taken to cross. The horizontal velocity is 3, x velocity, time taken to cross is 250. So hence it will be 750 meters. 250 seconds and 750 meters is the answer. Cool, everyone? Awesome, awesome, guys. Yes, very good. Let's find out. Yes, 15 minutes and 750 meters. 15 minutes because you can convert that 250 seconds into minutes and all of that. No Nikhil, not 4 kilometers. Okay. So basically, what do you see? Every single time, whether it is this case, this case, this case, it's generic formula every time. To cross, crossing direction is this, so only consider that velocity which is the resultant y velocity. For drift, use the resultant horizontal velocity. That's it. Okay. So these were your riverboat problems. So now it's time, I think, for yes, rain man problems. Okay, let's do the final part of this, which is the rain man person question problems, where a person might be moving and you have to decide which direction should he hold the stick of the umbrella so that he does not get wet or gets least wet. Okay, so those are the kind of questions. Now, why does he have to change the angle, you might think? Well, see, if the rain is falling vertically down, then the stick of the umbrella will also be vertical so that he does not get wet. It will be foolish if the rain is coming from the top and you're holding the umbrella like this. Obviously, you will get more wet. Probably your legs might get more wet. Correct? Now, just imagine the rain is falling at an angle. The rain is falling at an angle. Sometimes it happens because of the winds. You might see the rain coming at an angle. What you have done? Even as a kid, without even learning physics, by intuition, you automatically tilt the umbrella stick so that it is parallel to the rain's motion. Parallel to the rain's motion and you do not get wet. Haven't you done this, guys? And plus it is monsoon. The speed is given as 4 kilometers per hour. It is given as 4 kilometers per hour. Yes. Oh, sorry. Sorry. My bad. Yes, you're right. This was 4 kilometers per hour, not 4 meters per second. My bad. So actually speaking, over here, this was 1 kilometer. So this was 1 kilometer per hour, and this was, sorry, 1 kilometer, and this was nothing but 4 kilometer per hour. So it will be 1/4. So it will be 1/4 of an hour, which is basically 15 minutes. It is basically 15 minutes. Yes, you are right. Correct. Thank you for putting it up. Okay, cool. Awesome. Now, now imagine you are running. Maybe you have a school bus to catch, or your train is somewhere and you have to run. So when you're running, I don't think the rain will be appearing to come at the same angle. It will come at a different angle because you are in motion. So when you see the rain coming with respect to you at a different angle, you will automatically tilt the umbrella when you are in motion. Doesn't matter what the person standing on the ground is seeing, but for you, the rain is coming at an angle, so you will automatically tilt accordingly. So that is what happens. So what matters is how is the relative velocity of the rain with respect to the person. Relative velocity of the rain with respect to the man who is moving. So if I write it down like this, velocity of the rain with respect to the man, this will be equal to nothing but velocity of the rain minus velocity of that man. That's it. That is the simple equation. VAB is VA minus VB. V12 is V1 minus V2. So VRM is VR minus VM. That's it, guys. That's all. So say for example, rain is coming like this. The rain is falling like this. Okay, and let's say our person our person, he has to catch a bus, so he is going to run like this. He has to run, he's running like this. How will he hold the stick of the umbrella which he is going to catch? How is going to hold the stick of the umbrella which is going to catch? So for that, use this equation. Velocity of the rain is in this direction. Velocity of the rain is in this direction. So just use vector knowledge, guys. That's it. Velocity of the rain is like this. Okay, for example, velocity of the man is in the forward direction. Velocity of the man is in this direction. That's okay. 1 second. Yep. Velocity of the man is in this. Velocity of the man is in this direction. But don't use Vm minus Vm. So do not use. Vm. See, Vm is here. Do not use that. What you need to use is negative Vm. Negative Vm. So negative Vm will be here. Maybe like this. Maybe this is what minus Vm is. This is your positive Vm. Use the negative Vm. So it is vector subtraction. So when you add these two, you will get the resultant velocity like this. So this is your VRM vector. So which means the person in this rain will hold the umbrella parallel to this line, So the umbrella will be held like this. The person who is moving, is running, is going to hold the umbrella while running like this, because for him, the rain will appear to come in this direction. For him, the rain will appear to come in this direction as per him. Okay, so that is how it goes. Understood, guys? So this is the vector subtraction which you have to use. At the end of the day, use geometry, use vector subtraction, resolution, formula, whatever you need. Basic vector subtraction, nothing else. This is the main equation. Cool? All right. It seems very unrealistic. So the rain is coming from behind of me, and imagine this person is holding the umbrella in the front, sir. It's crazy, but it is true. Okay, let's see if you guys can solve this. By the way, let me meanwhile just ask the lecture to be shifted. I have a lecture on another channel at 8 o'clock. Meanwhile, let me just ask it to be shifted. Okay, that's all. A man is walking with a speed of 3. Due east, rain is falling vertically down. Find the direction in which the person should hold the umbrella. The rain does not wet him. Okay, simple. Man is working with a speed of 3. So velocity of the man is 3, like this. The rain is falling vertically down. So velocity of the rain is like this. How much is it? Where is it? 4. So VR minus Vm, I will need the negative Vm vector. So negative Vm vector will be here. Magnitude wise, it will still be 3. Obviously, magnitude wise. Okay, magnitude wise, it will still be 3. No change in that. This is the negative Vm vector. So Vr plus the negative Vm vector will be like this. So this is your Vrm. Remember, Vrm is Vr plus negative Vm vector. That is what it was all about. So how much is this going to be? Hypotenuse, right? So magnitude wise, Vrm will be 4 square plus 3 square, whole thing under the root, which is basically 5 meters per second. So that is the relative speed, but you have to find the direction in which he should hold the umbrella. So how much is this angle going to be? How much is this angle going to be? So guys, tan theta is 4 by 3, which means theta is 53 degrees. So 53 degrees horizontal, with horizontal, and also 37 degrees with vertical, the complement. 37 degrees with vertical. So you see the option 37 degrees with the vertical, yes, or 53 degrees with the horizontal. Perfect. This is correct. Yes, that is the answer. Moving to the next question on your screen. The man standing on the road holds his umbrella at an angle when he's standing so that the rain is away. That means he does not get wet. He throws the umbrella and starts running. He wants to enjoy it. He runs at 10 kilometers per hour. He finds that the rain is falling down. What is the velocity of the rain with respect to the road? So there are two scenarios here. Both the times the rain velocity has not changed. So the rain actually is falling at an angle with the vertical, making 30 degrees. So if you look at the vertical, guys, it is making 30 degrees. This is the velocity of the rain. Clearly mentioned, the rain is coming at 30 degrees because the person has to hold the umbrella at 30 degrees with the vertical to keep the rain away. Throws the umbrella, starts running at 10. He finds the rain is falling vertically down. That means VRM is like this. Okay, velocity of the rain with respect to the man is like this. That means because VRM is VR plus VR plus negative VM. VR plus your negative VM. That means your negative Vm will be here. This is your minus Vm. Vr plus negative Vm by triangle law is this. That means the velocity of the man is in this direction. That is what the person is going. Find the velocity of the rain with respect to the road. Okay, perfect. What is the man's velocity? The man's velocity was given to be 10. So minus man's velocity is also going to be 10. In this triangle, I think I will find which ratio? Opposite hypotenuse. So sine theta. So sine 30 is opposite, which is negative Vm's magnitude upon the rain's velocity. Negative Vm's magnitude is basically 10. Rain's velocity do not know. Sine 30 is half. That means the velocity of the rain is 10 into 2, which is 20 kilometers per hour. 20 kilometers per hour. That is the correct answer. Simple geometry. I said you again and again, guys, it's just drawing the diagram using vector subtraction. If you know how to do vector subtraction either through triangle or geometry, analytical formula, that's it. That is the answer. Very good. Let's move to the next question on your screen. There is a girl standing on the road, holds her umbrella at 45 degrees with the vertical. She starts running with this much speed. The raindrops hit vertically the speed of the rain with respect to the moving girl. Isn't this question very similar to this? Isn't this question very similar to this? Exactly the same question, guys. The rain is coming at an angle of 45 degrees when the girl is standing. So this is how the rain is coming, making an angle of 45 degrees. That's it. That's all you have to do. The rain is coming at an angle of 45 degrees. The girl runs with some speed. The raindrops hit her head vertically. That means VRM is like this. That means your negative VM is like this. That means your positive VM is like this. Positive VM is 15 root 2. So negative VM is also 15 root 2 magnitude wise. This is 15 root 2. This is 45 degrees. Isn't it obvious that this will also be 45 degrees and VRM will also be how much? 15 root 2 because it is isosceles triangle. Each side will be 15 root 2, 15 root 2. So how much will VR be? It will be root of 15 root 2 square plus 15 root 2 square, which is 15 root 2 multiplied by root 2 into root 2, 2 into 15, 30. So answer is 30. Let's see. Yes, 30. Oops, did we do something wrong? Oh, we had to find VRM. Acha, we just had to find the velocity of the rain with respect to the moving girl, which is 15 root 2, which is also 30 by root 2. Yeah, we didn't have to find VR, we had to find VRM. So VRM, yes, is basically 30 by root 2. We can just multiply by 2 by root 2 and divide by root 2, you'll get the same thing. Multiply by root 2 and divide it by root 2. Root 2 into root 2, 2. 2 into 15, 30. Root 2 remains below. Cool? Everyone? That's the answer to that question. And we have come to an end of the class. Previous question answer is northwest or southwest? This one? Which are not this one? This one? So that he does not make it wet. So the angle which he makes with the vertical, is towards, see, the stick of the umbrella is like this. And which direction is going? He's going towards the east, right? This will be the east. So if you measure it with the vertical, this angle will be 37 degrees. So 37 degrees with the vertical assuming this is the stick of the umbrella. Yeah. Towards east, 37 degrees with the vertical towards the east. Why did they say west? My goodness, that is wrong. 30, man is walking towards the east only, right? Yes, perfect. Rain is falling down so that it does not win. Which direction is man should hold the umbrella? Not towards the west, guys. It is towards the east, not towards the west. That is wrong. Yep. Correct. Awesome. So, what are you going to do? So, what are you going to do, guys? After this, mark the answer. I had given you one homework question. I don't know where it went. Somewhere. Yes, give the answer to the homework question of the two-dimensional problem. Remember, hexagon question. The answer in the comments. I want it. Okay, immediately after the class, I have shown you how to solve that question. And of course, any lovely comment, any heart, any emoji that you want to put it up in the chat box in the comments is utmost welcome. After this, we'll do capacitors. Okay, the 12th standard topic. Then we'll do combination of capacitors and resistors, series, parallel, etc. Cool. So that is the flow of the lectures, guys, in the road series. Like the session, share the session, watch it again wherever you find a problem. Okay, and keep supporting the biggest and the only trustworthy English channel, and that is the Vedantu JEE English. Thank you so much. Have a great time. This was Captain Shreyas signing off. Hasta la vista. Take care.